Now, considering doing an illustration in the remaining time, December 2023, question 2B. December 2023, question 2B. Scores Limited has experienced stockouts occasioned by the company's poor inventory estimation techniques. The company has therefore engaged you to estimate its demand for the year 2024. The company's accountant had started using regression analysis and availed the following information to you. The demand for the company's product is dependent on disposable income and price of the products. Number 2, the analysis of variances table. The analysis of variances table, we have a source of analysis, you have model, there is error, another column there is degree of freedom, and sum of squares. Number 3, the parameters estimates, the parameter estimates and the errors. 1, we have a column there for variable, estimate, and standard error. We have constant, we have price and price. Required: develop a regression equation that will be used for prediction. Roman 2, determine the coefficient of determination. Interpret your results. Roman 3, test the adequacy of the model for prediction. F table's value is 11.56. It was quite direct, this one. It was quite direct. Develop a regression equation. First of all, you have to put down the regression equation, then you insert the inputs. Multiple linear regression allows one to determine the effect of more than one independent variables on a particular dependent variable. So there are more than one, multiple predictors. Multiple predictors. So Scores Limited has experienced stockouts occasioned by the company's poor inventory estimation techniques. The company has therefore engaged you to estimate its demand for the year 2024. The company's accountant had started using regression analysis and availed the following information to you. Number 1, the demand for the company's product is dependent on disposable income and price of the products. Number 2, the analysis of variances table as shown. ANOVA, that is the ANOVA, the analysis of variance. We have the degree of freedom, that is model, source. Then there is the error. Then you have total. Number 3, the calculations have already been done, candidate. So we have almost almost everything that is required. You can see that the sum of squares is given. The sum of squares is provided. That's why I say the question was quite direct. Then number 3, the parameters, the parameter estimates and their errors. There are 3 columns there: variable, let me confirm something. This is question number 2B. So we need to change candidates. There was an error there. You can see not in number 3. Number 3, I was to confirm that because because of the repetition. That last price there is income, not price. The parameter estimates. The parameter estimates, that is income. That's what disturbed my mind. I had to confirm from the original paper. So the values are okay. So that total, we have 3 plus 9, 12, 187 plus 4, it's 191. So develop Roman 1, we have to develop regression equation. Develop regression equation. Develop regression equation. December 2023, question 2B. This is December 2023, question 2B. Roman 1. What is the requirement? Regression equation. We have independent variable y being equal to beta naught plus beta 1 beta 1 beta 1 x1 plus beta 2 x2. So how many variables do we have here? How many variables do we have? Lumia, how many variables do we have? How many variables do we have? These are 2. All right. Plus error. So we check from the question. Do we have beta naught? The intercept. Look at the question. Look at note number 3. Note number 3. We have the constant. Look at the constant. The parameters, the estimates and their errors. We have this constant 1.1 represents the intercept 1.5 plus beta 1. Our beta 1, look at the question, candidates. Look at the question. Look at the question. Look at the question. We read note number 1. The demand for the company's products is dependent on disposable income. So the dependent variable is y, and it is dependent on disposable income and price of the products. So there are 2 dependent variables. That is the price and income, dependent on disposable income and price. So we have income and price. From note number 3, you can see the price is 1.5, negative 1.4. That is the price, negative 1.4. So we have plus negative 1.4 x1. Then the next dependent variable is the income, and the income is 5. We have 5 x2 plus error. Y is equal to 1.5 minus 1.4 x1 plus 5 x2 plus the error. the error term. Then note number 2, what are we required to calculate? Determine the coefficient of determination, then interpret the results. Now, what is the coefficient of determination? Now, the coefficient of determination is the R squared. The coefficient of determination in cost estimation is the R squared. And it is a statistical measure that indicates the proportion of the variance in the dependent variable cost. It indicates the proportion of the variance in the dependent variable cost that is explained by the independent variables or the cost drivers in the regression model. And we know it ranges from 0 to 1. It ranges from 0 to 1. So if you have R squared of 0, that means that the model explains none of the variation in the dependent variable. Alright? But you have R squared of 1, then the model explains all the variations in the dependent variable, all the variation. But what is the formula for R squared? Coefficient of determination. Roman 2, coefficient of determination, often abbreviated as R squared. R squared. So what is the formula for R squared? Now the formula for R squared is equal to SST. That should be R first. SSR over SST. SSR over SST. SSR over SST. SSR R over T. SSR over SST, where SSR is the sum of squares due to regression. Sum of squares due to regression. Then SST is the total sum of squares. The total sum of squares. Do you see that? SSR is the sum of squares due to regression. Sum of squares due to regression. We divide by the total of squares. The total of squares. Total of squares. Total of squares, SST. This represents total. This is regression. Sum of squares due to regression divided by the total of squares. So what is a SSR? Look at the question. SSR. Look at the question. SSR. Now look at note number 2. The analysis of the variance. Note number 2. Note number 2. The model. Look at model. The sum of squares. Can you see that? We have the sum of squares. Then we have the error. So the sum of squares is given at 187 and the total is 191. So this is equal to 187 over 191. The total is 191. 191 is the total. Now give me the r squared. Should be 0 point something. Is 0.98. This is the r squared. And we've said that the coefficient of determination is a statistical measure that indicates the proportion of the variance in the dependent variable cost that is explained by the independent variables, which are the cost drivers in the regression model. The cost of determination, r squared, indicates the proportion of the variance in the dependent variables that is explained by the independent variables, and it ranges between 0 and 1. So you can see this one is 0.9. It is close to 1. And I did say earlier that if the r squared, if the coefficient of determination is 0, that indicates that the model explains none of the variation in the dependent variables. But if it is 1 or close to 1, the model explains all the variation in the dependent variable. So a higher r value indicates a better model fit. A higher coefficient of determination, in other words, suggests that the model is more accurate in predicting the cost. It suggests that the model is more accurate in predicting the costs. So we've calculated the coefficient of determination in this question that was tested in December 2023. The coefficient of determination is 0.98, which is close to 1, which means that approximately 98%, because 0.98 is just 98% when converted into percentage. That tells you, that means, and now I'm interpreting, that approximately 98% of the variance in the demand can be explained by the independent variables. That is the price and income, because those are the independent variables. Interpretation. Because candidates were required to give an interpretation of the r squared of 0.98. 98% of variance in demand. 98% of variance in demand, because demand, candidates, is the dependent variable in this question. So 98% of the variance in demand can be explained by the independent variables. Can be explained by the independent. But if it was to be 0, then that means that it could not be explained. If it's 0, the model explains that none of the variation independent variable. The model explains none of the variation. But if it is 98%, which is close to 1, then it means that 98% of the variance in demand can be explained by the independent variables in this question. These are the price and income. Price and income in the model. Price and income are the independent variables in the model. It indicates a strong explanatory power of the regression model. That is the interpretation. And that is part 2. Part 3 of the question reads, test the adequacy of the model for predicting or for prediction of F table's value 11.56. Now, to test the null hypothesis candidates that all the slope coefficients in the multiple regression model are jointly equal to 0 against the alternative hypothesis that at least one slope coefficient is not equal to 0, we must use an F test. So the null hypothesis is that all the slope coefficients in the multiple regression model are jointly equal to 0. That is the null hypothesis. But we need to carry out the test. And we know the F test is viewed as a test of regression's overall significance. The F statistic measure. The F statistic measures how well the regression equation explains the variation in dependent variable. In other words, candidates, this one is just a ratio of the mean regression sum of squares to the mean squared error. So we need to calculate the F statistic. So what's the formula for F? F calculated. It is a ratio. Mean regression of some squares. This is equal to mean regression of some squares. Just two things. The mean regression of some squares and the mean squared error. We divide it by the mean squared error. Which is equal to, first of all, we need to calculate the mean regression of some squares. The mean regression of some squares will be equal to RSS over K. We divide that fraction by another fraction, SS. This should be SSE. SSE. We divide it by N minus K plus 1. N minus K plus 1. Or simply, can simply be just MSR we divide by MSE. The F statistic, where RSS is regression sum of squares. Regression sum of squares. Regression sum of squares. Mean regression of some squares. Alright? Regression sum of squares. And K, we are dividing this by K. K is the number of independent variables in the model. number of independent variables, and in our case there are two. It was there are two. We have price and income, independent variables. This is number of independent variables. Then you have k plus 1. K plus 1 is the total number of parameters to be estimated. How about SSE? Now, SSE is the sum of squared errors. The sum of squared errors, all right? SSE is the sum of squared errors. And the N, of course, is the total number of observations. So we are dividing with the k and k plus 1 so that we can get the mean. It's just the same thing, candidates, to get this mean in the first statement. So we are dividing with the k here and n minus k so that we can get the mean. So it is just the mean regression of sum squares minus mean squared error, and this is the formula for mean regression of sum squares. This is the formula for mean squared error. So there are two things, the mean regression of sum squares and mean squared error. These are the formulas for the two. You understand? Is that clear? Let's move to the third one here. We're just trying to expound and look at it from different perspectives. Now, MSR is the mean regression of sum squares. Mean regression of... Do you understand? MSR is the mean regression sum. The mean regression sum of squares. MSE is just the same thing, candidates, here. MSE is the mean squared error. So let us land. We are now landing, candidates. We have to calculate the F statistic. F calculated. So from the question, we have these values. Look at the question. Look at the question. Do we have the values? RSS. What is our RSS? RSS is 187. You see that? 187. The sum of squares is 187. It has already been calculated. So just insert the input. That is 187 divided by 2. 187 RSS you divide by 2 over our SSE. SSE is the sum of squared errors. We have the sum of squared errors from the question. Sum of squared errors. Yes, the errors you can see there. The sum of errors from the table is 4. Then we divide by n. What is our n? Our n from the analysis of variances. Yeah, the total there is 12. Degree of freedom, that is 12. All right, that is for 12. So we have 4 divided by n, which is 12, minus k, we know is 2 plus 1. That's it. Give me the F calculated. F calculated. F statistic. How much is it? F calculated. Give me the F calculated. F calculated is equal to Sarah. I'm waiting for F calculated. Is it greater than 11.56? The F table, the F tables. Give me the F calculated. Johnny says 210.375. 210.375 is the S calculated. What does that mean? Or what are we required to you do with that? Test the adequacy of the model. That's the question. Test the adequacy of the model for prediction. So to test the adequacy of the models of prediction, where the F tables value is 11.56, we have to first calculate the F calculated. And the F calculated, we see here, and this is more than the 11, is it 11.56? Yeah, the F calculated, and this is the test. F calculated is greater, is it not? Is it not greater than the F tables? The F calculated of 210.375 is greater than the F tables of 11.56. What does that mean? Here we reject the null hypothesis that all the slope coefficients in the multiple regression model are jointly equal to 0. We reject the null hypothesis that all of the slope coefficients in the multiple regression model are jointly equal to 0. Remember, that's what we said at the beginning. And that means that the regression model is adequate for prediction because the calculated F statistic, the calculated F, is significantly larger than the critical F value tables. And that is to say, that is to mean that the model provides a statistically significant explanation for the variation in the demand. Because the demand, we know, is the dependent variable. It is the dependent variable. The total cost in this question depends on the price and the income, which are the independent variables. So a larger F statistic, which is the calculated statistic, we've seen is significantly larger because we are talking about 210.375 being larger than the 11.56. It is significantly large, as was the case for the coefficient of determination, which was 98%. 98% of variance in demand explains that the independent variable, it can be explained, okay, by the independent variables, that is price and income. And therefore, the model provides a statistically significant explanation for the variation in the demand. So that is what was required for that version that was tested in December 2023. Any question? Thank you for attending the lesson. Bye-bye.